Okay, so distance between a point and a line in R2 again. This question is a little different. They've given us a point. They want us to find the difference or the distance between this point and this line or this vector. But this is in vector form, this equation. And remember, for our equation, we needed it in what form? Anyone remember? Cartesian, okay? Because our formula is ax naught plus by naught plus c, all divided by the root of a squared plus b squared, which means we need our Cartesian form. So our Cartesian form deals with the normal. Now there's a couple ways we could go about figuring this out. Because we're in 2 space, it's actually quite easy to find the normal in this question. Remember, this kind of deals with slope, our direction vector here. So we know the negative reciprocal of that will give us our normal for the equation. If you're not used to solving it that way, we could also put this into parametric form in order to solve it. So we'll quickly show, because the negative reciprocal of that would be actually positive 3 and 4, we know our Cartesian form is going to be 3x plus 4y, and then we'd have to find c is equal to 0. I shouldn't have 2 equal signs there. And we would just plug our point, -2 and -1, in for x and y, and that would help us find c. Another way we could do this is put this in parametric form. So let's say we did plug that in actually. Before we put it in parametric form, 3 -2 plus 4 -1 plus c equals 0. -6 minus 4 plus c equals 0. c is 10. Okay? So we'd have 3x plus 4y plus 10. Another way we could have done this, x is equal to -2 minus 4s. Y is equal to -1 plus 3s. If we then instead equate these to the value of s, okay? So remember our symmetric form. We're going to equate these to s. This would then become s, or our first equation would become s is equal to x plus 2 divided by -4. Zoom in a little. And our second equation would read s is equal to y plus 1 divided by 3. We could then put those two together because we have a value of s for both. X plus 2 divided by -4 is equal to y plus 1 divided by 3. Cross multiply. 3x plus 6 is equal to -4y minus 4. We move these two to the other side of the equation. 3x plus 4y plus 6 plus 4 equals 0. And we would have found the same thing we had before. Whichever one is easier for you, okay? Both times we found the Cartesian form of the plane. In this one, remember, c was 10. We just found it at the end. And here we just equated it just now. C is 10 again. Either way is fine. So, once we have our Cartesian form, we just have to plug our values in. It'll be very quick from here. D is equal to the absolute value. Our A value is 3. Our x naught, which is a point along the line, is -2. Our B value is 4. Our Y naught is -1. And our C value is 10. I'm going to zoom in again. All over the root of a squared is 3 squared, b squared is 4 squared. So, absolute value of -6 minus 4 plus 10. Oh, I plugged the wrong point in. Thank you very, very much. I was wondering why we're ending up with 0 there. So, I made a silly error. I called this our x naught and y naught, but our x naught and y naught should be the point we're trying to find the distance from. 15 and 9. So 15 and 9, 15 should be x naught, -9 should be y naught. So we're going to make a quick little change here. little substitution. (15) and (-9). Very different answer this time. 45 minus 36. Ah, nuts. There we go. All over the root of 9 plus 16. Okay. 9 plus 16 is going to be what? Which in the root of 25 is? 5, so we got that. And 45 minus 36 is 9 plus 10? 19. So our distance is 19 divided by 5, which ends up being 3.8. Okay. A little more work to that one. We had to change it into our Cartesian form.